And this is Michael Erdmann. He's from Enterprise, by the way. I normally don't, I think we don't need to introduce speakers. This is a semi-structured conference, except for the keynote speakers. So go ahead. If you do have a presentation, just come on and do it. All right. Thanks.
Yeah. Thank you, Jason. So I'm going to talk about SMW a little more, especially its data integration features. SMW was introduced by Daniel yesterday already. So data integration has, this is the agenda, maybe not so important. This presentation will also include some demos. I hope they work well. So data integration has to do with, you all have data in your companies or your customers have data. And typically this data is stored in a relational database. Nowadays we see Sparkle endpoints and triple stores as well, but nevertheless I think the majority of data is still in relational database. And typically there are many of them, they are separated. The thing called data silos, they are developing independently, but nevertheless they somehow should work together and should be accessed in a unified way. Wikis typically are somewhat different. They are meant for sharing information. Be one place where multiple people or maybe even departments can work together and share information. But a wiki will not get rid of the databases. The databases do exist. They have valuable information. Sometimes they are mission critical. That means they have to be there in exactly the same way as they are, and they will never be deserted. And in enterprise use cases, there is often a need to combine both sides, the database world and the wiki world. And main use cases are, okay, I have this data, I want to access it, I want to make it available to the wiki users, and in that sense, the wiki becomes a kind of data access and visualization tool. And since it's a wiki, users can cooperate and the community can do something with this data. So if you have any questions, just jump in. So I will not only show you SMW or the wiki side today, I will also briefly introduce another tool from Enterprise. This is called Onto Studio, which is an ontology modeling tool. It's a desktop application which allows you to, what I like to call, lifting the database. You have a database at the bottom, having schemas, tables, columns, foreign keys, and so on. And lifting means, okay, we take this schema, make it like this, and we come up with an automatically generated ontology, now talking about this database in terms of concepts and properties and so on. And if we do this lifting, we can stay in the ontology world if you want. And then you have multiple databases, they have different schemas, they conflict, they represent possibly the same knowledge in a different way, and the wiki also has categories and properties. We have to bring all those schemas together somehow. This is done by creating mappings. Mappings is also one of the features of Onto Studio, and at the end of some work in this client desktop application, we'll have a couple of ontologies. One representing the database, another one representing the conceptual model or the schema in the ontology, and then we can export those ontology and make use of them in the wiki world. And in the wiki world, the main goal is to be able to formulate queries against this data, and these queries will go against the database's life. That means the content of the database will change, the result of the queries will change also. And it also allows browsing in the data in the database and so on. So. And of course, we can also go back and complete the full cycle. Before I go to the demonstration, the architecture is more or less like this. At the top, we have the wiki SMW+, which is the application level, which is the client, the user of the data. In all the semantic wikis, we create annotations, and they are stored as semantic tags in our triple store in our data storage layer. And in SMW Plus, we can even handle ontologies and rules, also created via pages in the SMW Plus in the wiki. The wiki can formulate queries and it can display results. The queries are sent to this triple store connector, which contains Ontobroker, which is our reasoning engine, and also the component which finally accesses the database and does reasoning and so on. And the database is on the lowest level, which contains the original data, and data flows up there. Database lifting consists of reading the database schema from multiple different database vendors. And these database schemas typically do not really reflect the conceptual model anymore. So if you recall your studies, you probably have heard about entity relationship modeling, which is very close to the conceptual model, what we nowadays call ontology. Database tables look very different. And these tables typically are geared towards making the queries performant and being able to store lots of data. And it's really hard to see the main model from those tables. The lifting takes this database schema literally. That means every table becomes a class. Every foreign key becomes a relation to another class. Every column becomes an attribute of this class. This is not a good ontology, of course. But nevertheless, it uses the same simplification language, let's say OWL or RDF. That means you can use the same tools for making use of this data. In our case, these ontologies are represented in another language, not OWL, but object logic, but the difference is not so important. The result of this lifting is a set of rules, in addition to the concepts and properties that I just discussed. The rules are there to access at query time, reaching down into the database and fetching the data. Since object logic is a rules-based system, those access rules are also object logic rules, making use of time. You can imagine, okay, at the query process coming from the wiki, we are finally creating some SQL statements here and collecting the data and translating, and in the wiki it looks like more or less ordinary wiki statements. Query. So actually I wanted to demonstrate how to do this listing. Unfortunately it doesn't work because the database is in Karlsruhe and VPN does not allow me to access it. But nevertheless I can show you the result of this. I can show you the slide. So this is the wizard for lifting the data. First you say, okay, where do I find the database? What is the port? Then you select, I want to see the tables of a certain user. And then you see all the tables with their columns. And then you can select, I want to import this table, this table, this table, this table, and so on. And you can also say, okay, also select all tables automatically which have foreign key relations. So if you select this, you click next. The result will be an ontology. What you see here on the left-hand side. This one I have a copy of in the system. So what's called PV ontology on the left-hand side is the result of this lifting process. We have a couple of concepts with properties over here on the right-hand side, and do I have some relations as well. So the names are not pretty. FK stands for foreign key. That means the crisis table, now concept, has a relation or a foreign key relationship to another table called cars or country. So that means the abstraction level between database and this now ontology is exactly the same. We're not doing any magic or something. We're just more or less representing the table, the different setups. And you can see these lifting rules here, but they won't look pretty. Trust me. So this is the internal object logic syntax, and not supposed to be read by humans, but the machine can understand. So now that we have an ontology representing the database, we also need one representing the wiki. That means the conceptual model that is relevant for the wiki users, which they can understand. And this also talks about the same things, namely prices, products, cars, and so on. But now this is a real ontology, representing a conceptual model, not just the rephrasing of the database. Of course, it talks about the same thing. And the important part comes now. We need to associate this database ontology with the wiki ontology, and this is done via mapping rules. And as you can see here, some of them have been already defined. For example, all instances of the prices, normally prices table, will be represented as instances of the price category in the wiki. And the properties are mapped, some of them are translated into attributes, others are translated into real relationships between instances. So I think that should be sufficient to give you an idea of how the setup process works. Now we can export these ontologies and import them into the wiki. Oh, I forgot one thing. In addition to just doing the mapping here, we can also formulate rules in this wiki ontology. And the rules make use of the data coming from the databases, but inferring new information. So we have some facts, we formulate the rules, which creates new information. So this rule here, for example, says, okay, please create me a new instance of the class revenue by product for every product, and relate this revenue by product to this product. And the value of this revenue by product instance is the sum of all the sales made for this product. So we're aggregating from them some values here and feeding the value into this field. Later on we will see that the wiki can not only query data from the database directly, but also infer knowledge from here. The inferencing process is executed by this Onto-Broker system, which is part of the triple store. And this is something that I cannot execute because of the VPN program. This is a sample query using the wiki ontology and asking for give me all prices and the product it is for, so we get a list of values and the names of products. So I will show this later. So this is the wiki without any ontology imported from the studio. When I use this SMW admin tool that Daniel also already demonstrated yesterday, we can see in what components are installed in the current wiki and which components are available in the repositories. And I can use the same tool to install, if you want, an ontology now. this one. I'm looking for the quotes. Oh, they come automatically. So now we're loading this object logic ontology representing only the wiki side, not the database here. So what's happening now is we're translating this ontology and importing the categories defined there, the properties defined there, all the rules that have been defined there. They're imported in the wiki, and something that's called external artifacts. External artifacts are those things which are part of the ontology, but which have no immediate representation in the wiki. Object logic ontologies can have arbitrary predicates, for example, or metadata or stuff. There's nothing like this in the wiki, but for doing the reasoning and accessing the database, and so this is crucial knowledge. So it has to be stored somehow in the wiki, but it will not be presentable to the users in any way. So it's essentially an external file. So the import has successfully completed. So if I reload this page now, we should see the same thing that we saw before. And of course, if I go to the ontology browser, the structure of the ontology that you have seen in the tool before is now visible in the ontology browser. So the products have cars and subclasses. But if I click here, nothing will appear because we did not add the database level yet. Even the triple store has not been started. So what you see here is the imported schema level is there. So properties for the classes are there. So before I continue, this folder on the left-hand side, this is the folder for the triple store connector. And if we want to make use of this database ontology, I have to grab this. And fortunately, I have a copy of this database ontology with the data materialized so that we can really see some data. And we put it here in this autoload folder and restart the triple store. By restarting the triple store, we are using the lifted database schema plus the access rules. We're loading them into the triple store that when we get some queries from the wiki, that we can find the data from the database. So, okay, triple store has started, it is loaded. Now we should be able to see also some data. Okay, so these are all the instances of the class car which are there in the database and have been lifted and have been translated, mapped in the wiki ontology. If we click on one of them, we even see some problems. Now you might ask the question, what does it see, parentheses, cars, long number, comma, and so on, what does it mean? Databases have, so we're talking about, if you want RDF now, everything that exists in RDF needs to have an ID, the URI. And these are automatically generated IDs that are created, URIs, by the lifting process. Based on what you see here, there are essentially the key properties of things that have been listed. And actually, this thing is not this long, but that, because it must be URI, and we have to make sure that there are no illegal characters in there.
So there's a paper.
Yes, they are paper.
Can they see the paper?
Very good. But they are not ordinary pages, because they don't exist in the wiki. They are virtual, if you want.
Oh.
If you click here, you get an automatically the template, if you want, saying, okay, you clicked on, actually this is the URI that has been created. It's more than one line long. So it's really, really, really awkward. And this is only half a line long, but still not much prettier. So what you see here is, okay, the object that you have clicked is an instance of car. It is an instance of the category product. It has some properties. It has a manufacturer. It has a name. This is the type information again. On the left-hand side you see, and other objects, namely those here, refer to this object using this property. So we have Audi A3, 71 million, I don't know what, as a product, the car that I just clicked here. And of course you can click here and browse the complete database in this way. We're always using the same template, for instance. But this template can be changed. I mean, if you know that you have prices and cars and so on in the wiki, you can formulate your own query, your own template using special queries, so that probably this doesn't make sense, but you could create a kind of info box instead, saying, okay, this is a car with this manufacturer and this price, I don't know what. So you have an info box here, and not the very generic queries that we have here. So this is essentially a Spark query saying, give me every subject and predicate where this page is an object. And this is the query, give me all predicates and objects for the triple this PO.
So you could generate one template per class then?
Yes.
Yeah.
Yeah. So you can manually formulate it.
Mm-hmm.
So we have one template for all instances, and then you can create one template for category car, one for price, one for sales, you name it. So now I lost. Okay, so what happens? So the content, the rules maybe are interesting. So in the ontology that we created, the wiki ontology, contains two rules. And the rules are all put together into one page. Did I do it? Are all put together into one page. So this is the rule defining the revenue by product, and this is the rule defining the revenue by country. The syntax here is object logic syntax, but pretty printed, and even if you don't really completely understand this, I think you can, with a little effort, understand what it is. But nevertheless, I'm not going to. Queries, I think, is something that you would think. So why don't we ask for those? So this is the standard query interface, which comes with the Hello extension or SMW class. Looking for the revenue folder. That is where. So at the bottom you also already see, okay, query, this query has been executed and created some result. Sounds good. Let's level that. So let's add property. We also want to see revenue is 4. Oh, damn it. This is not a good product. So maybe instead of looking for the object with this strange URI, which no one understands, maybe we should do something else. Maybe we should ask for some property of this product instead. So maybe his name is. Change this and okay, this is. So we have another property, namely the value of the revenue. Okay, this makes sense, and we could get rid of this one. Daniel, do you know how to get rid of this main label? What is it? Minus? And finally, we have a really good query, good looking query that we can put into pages. Okay. Do you want to see the external thing? Oh, it's just a file. Just something stored. So not really interesting. So of course we cannot only use the query interface, but also inline queries. Let's just create one. What you see now is should allow you to see, okay, I can access the data, I can write pages, I can comment on some data, I can formulate the queries and discuss the results with my fellow wiki users. So, and this now is embedded in a page, and you can do with it, within this page everything that you
So this is pulling data from the database, right?
Yes.
Dynamically, right?
Whenever the query is executed, we are, maybe this is a good time where I can show the slide. So this is more or less the same architecture as before, and the layout is a little different. Wiki, triple store with reasoning engine and original data. And the workflow is like queries. SMW sends the query to this triple store connector using the wiki ontology as a vocabulary, a language. Then the mapping rules, which have been formulated in this direction, mapping database ontology into the wiki, are executed, and the lifting rules are executed, and on the way back everything is translated into first this ontology, then this ontology, and this is the language that the users of the wikis also see, because this is a language that they know. They don't know those things. What you can also see here is in the mapping step, we can integrate multiple sources. We can translate them, we can merge information, and we can make all of them accessible using this single vocabulary, which is exposed to the users. And this process happens whenever a query is executed. So, those two nice figures represent the wiki ontology. This is the part which is loaded into the wiki, including the mapping rules and the metadata for the mapping and so on. This thing here lives only in the triple store because it not really relevant for wiki users, but it's relevant. This is if you want southbound facing, and this is the northbound database.
So the first thing that you did with your SMW and this map of rows, you had to get the rows in there before you could start. That's
Exactly. SMW admin loaded this on top of it. And this one was
so
magically
you have to
for-
update that regularly, like the database. The structure doesn't look like.
I don't understand.
I mean, you'd have to run it again if you had made structure changes.
If,
Yeah, I guess. you do.
okay, what changes the database? This side or this side? Where do you
Yeah, but
expect
actually,
changes?
never mind. It's just that. Never mind.
Okay. Okay. So I presented this, except for the export, but I think that's also not so important. And check this. Show this, show this, show this, mixing this, and this, and this. So I think I have some more time, right? Who's the timekeeper?
Just 15 minutes.
Okay, so that means I will probably be quicker than expected. But one additional feature is, okay, now we can access the data and we can write text and images. I don't know what is in addition to the queries, but can we also extend it? Can we enhance it? And the answer is yes, to some extent. You can change everything that can be changed in the wiki. That means you cannot delete stuff from the database because it's inaccessible, it's read-only. You cannot overwrite stuff from the database, but you can add additional things to it. So, and why don't we do this then? So, I'm trying to model this. I want to model a new category called top seller, which might be a subclass of a product or car or something. And top sellers are those cars which have a revenue of more than 900K. So look at the revenue and create instances of this new class depending on some properties. Actually, I didn't expect to be required to do this, but that means we're creating a rule for defining instances of this class. On the left-hand side, we now can define the content of the rule. So x1 belongs to this class if x1 is a car. There's something else, which is this revenue bar product, and this something else. Don't know the right property pointing to the car. No. Not the right thing here. I don't understand why has product is not true.
Okay, my rule has been. Did someone see what happened?
Did you save the page?
The rule is not there anymore. Okay. So I will simplify the rules grammatically. I will say every car is a top center just to show that. Okay, I cannot show.
For some reason, the rule editor.
You just be refreshing it, not refreshing the page.
No, I don't think so. I don't know what goes.
I apologize for that. But just imagine I created a rule and I can create query asking for instance of this new thing, and logically now I would not only apply the lifting rules and the mapping rules and the rules from that I created in Content Studio, but I would additionally apply some rules defined in the wiki itself. But that means I have a long chain of rules, finally resulting in a combined query based on the original data from the database. So I think this is the unsuccessful end. Okay, exporting, not export. So
Yeah, and if I would have been able to formulate the rule, you would also be able to see this rule in Content Studio and continue the site. So that's it. Any more questions?
Is there a demo available on the web or like a website running the software that we can look at?
I don't think so, but we could create a video of this, which allows you to see it working. But the live system, I'm not sure that we can set this up, especially since the first half of the presentation would not be visible, because this is a desktop application.
But basically, it's true that the configuration, what you saw, is made of industry grade software products from